Here we have a question that focuses on working with arc lengths of a circle. Now it sets it all in a scenario of being part of a football pitch, but it then basically breaks that down and gives us the arc that it wants us to focus on. So essentially what it's doing is setting a scenario and then saying, well, scenario doesn't matter, the maths is the part that matters. So a lot of times with questions like this, it's all about interpreting it, and it actually gives you the right information itself. We don't have to worry about interpreting the picture of the football pitch too much. So it gives us the part of the circle there. What it then says is that AB is the arc of the circle, C is the centre, radius is 9.15, and it wants the length of the arc AB. Now for this one, we have to start remembering formula. Now unfortunately, arc length and area of a sector are not in the formula list, so these are two of the formula you're expected to remember. Now for the arc length, what we have is we do theta over 360 times pi d. Because arc length is a part of the circumference of the circle. If you think of it like a pizza, arc length can be thought of as the crust of the pizza going around the edge. So it's a chunk of the circumference of the circle. Now to find the fraction of the circumference is, we do theta over 360, where theta is the angle at the centre of the sector we're looking at. In this case, 106 degrees. Now one thing to note is I've written it as theta over 360 times pi d. Sometimes we're given the radius, as we are in this question. So as we normally would with circumference, we can rewrite the pi d to be theta over 360 times 2 pi r. So we can use that as well in some scenarios, and in this case, I'd expect you to use it for this one. So here we have the calculation being arc equals 106 divided by 360, so that tells me the fraction of the circle I'm going to use, times pi, times 2, times my radius, which is 9.15. Because remember, in this case, it gives us a radius rather than a diameter. So now I know the calculation I'm going to do, now I know what I've got, I can just fire it straight into the calculator. There will be some questions where it may ask you for your answer in terms of something times pi, or it may give you numbers such that you're able to actually work it out yourself without a calculator. In that case, it'll be really, really nice numbers that it will give you. Generally, it'll be something like this, so where it's a calculator question, where we fire it in the magic number machine. Once you do that, what you'll end up getting is an answer that says 16.927, and then it continues on. So this sort of answer here, we could round to 16.9 meters. Mark scheme says as well, they'd accept 17 meters as a final answer. If you rounded to a whole number, I'd suggest keeping a decimal place in, just so you've got it. So it's a fairly straightforward set of steps. The biggest thing is remembering the formula for your arc length and what the parts of it mean. So the theta, the d, the r, etc. And remembering where those come from in your diagram. Once the diagram's set up, so in this case it does it for you, there may be some where you have to draw it yourself just so you can put the information on it. Once you've got that, it's reading off the information and sticking it in here. So this question here, 3 marks. You get 1 mark for doing your 106 over 360, so identifying the fraction of the full arc that you need. Second mark is for the full calculation step, so i.e. 106 over 360 times pi times 2 times 9.15. Then your third mark is for your final answer. Now again, it'll accept 16.9, it'll accept 17 for this case here. You'll be fine like that. Don't be silly and round it to 20, because that just is totally nonsense. Yeah, you lose a complete degree of accuracy with that. Don't round it and be silly, unless it asks you to for something like that. Stick with, in my opinion, 1 decimal place. So a question like this, if you can remember those formula and where the parts come from interpreting the diagram, you should have no issues with a question like this. No major issues whatsoever. If you can identify those parts, it'll be easy peasy, lemon squeezy.